Welcome to another video on organic reaction. Organic reactions. Now we have a lot of organic reactions, but we are going to be checking like 15 of them, 15 or more. Now, once you know these organic reactions, believe me, the organic chemistry will be simple. Now, what am I talking about? Now, every compound has one or two reactions in which they take part. Now, when you observe, when they say something like hydrogenation, hydrolysis, it is something like that. We have a lot of organic reactions like substitution reactions, addition reaction, oxidation reduction, saponification, polymerization, esterification, condensation, all those things. We have carbonylation, ammonolysis, polymerization, etc. Now we'll be looking at this. With the knowledge of this organic reaction, believe me, you are good to go with organic chemistry. Now you have to say it and follow these lectures very well. Now, but before I talk about some reactions, now don't forget in organic compounds, due to the carbon as the major element of the organic compound, I explained this under hybridization. Now, the carbon has the ability to attach with four different atoms. Now, majorly we have hydrogen, but not only hydrogen. Now, any other atoms. Now, if you see this, something like this, let's examine this. Now, it's obvious that this carbon here must have a bond here, 1 and 1. Making this carbon to be 1, 2, 3, 4. Can you see the bond? And this one has this bond 1, 2. That means we have 3 and 4. Make it to become 4. This one as well, it's already attached to this. Another bond will be here. We have another bond. We have another bond. So in organic compounds, carbon atom must have 4 bonds. It must not be lesser and it must not be greater. Now, in the case of double bond, now if an organic compound has a double bond, something like this, now you observe that this is double bond. So this is 1, 2, 3. So that shows that this carbon must have 1 to make it to be 4. That's why it is 1, 2, 3, 4. Now, this one at the middle is 1, 2, 3. So that means it needs 1 to make it to be 4. That becomes 4 here. So that's it. You cannot have any additional 1 here because this one already taken 2. So that's why this one is what? 4 like this. But this one has 1 here. So it's going to 4. That's 3 here, 3 and 4. And as you can see, that if you compare this with this, they are different. The reason is because there is double bond here. The same thing goes with triple bond if you have something like this. Now you observe that this carbon here, this carbon has 1, 2, 3. So that means it needs 1 to make it to be 4. This carbon here is 1, 2, 3, 4. This one already completed. So we cannot add anything to the upper or to the below here. But this one is 1 here. So we need 2, then 3, and we have what? 4. Make it to be completed. Now, this is the basic knowledge of the carbon bonding in the organic compound. And don't forget that organic compounds undergo covalent bonding. It's undergo covalent bonding, and that is one thing about organic compound. Now let us proceed to the organic reaction. Now for the organic reaction, as I said, for the organic reaction, the first thing I will be looking at is number 1, we have substitution reaction. Now what is substitution reaction? Now as I'm looking at substitution reaction, I'll be looking at addition reaction because number 2 here, I'll be looking at addition reaction or additional reaction. Now I'll be checking the two at the same time. Now what is substitution reaction? Substitution reaction can also be known as replacement reaction. Now, and at the same time, the addition reaction is not replacement, so it's opposite. Now, if you are saying substitution reaction is is a process in which atoms of the organic compound is being replaced by an atom or group of atoms. Now, that's why we can say it is also known as substitution replacement reaction. Now, this substitution reaction is peculiar to saturated hydrocarbons, yes, or saturated compounds generally. Now, addition reaction is the process by which there's a direct addition of atoms to group of atoms of an organic compound. Now, this one deals without replacement. This addition reaction deals without replacement. There will not be replacement. So it will just be one direct addition or without elimination. Now, when you're talking about addition reaction occur in unsaturated hydrocarbons or unsaturated compounds. Now, when you are talking about the difference between saturated and unsaturated, saturated are those compounds that are filled already. Like when I was explaining this the other time, you observe that this compound here, it's already saturated, it is filled. There's no space to add any additional atom to this. But this one are yet to be filled. There's still a space here, there's still a space here. So that's why we can call alkane or saturated. And at the same time, check this alkyne. There's space there, there's space there, there's space there, there's space there. So we can stretch this in order for other atoms to come in. So that's why this alkyne and this alkane can be known as unsaturated. And that is why this alkane can be known as saturated, because it is filled already. There's no space to add anything. So if this alkane wants to undergo any reaction, then it has to substitute any of the atoms here to replace the atom that need to be attached with it. But this one, it still has a lot of space here, so to attach with it. So that's the difference between the saturated and unsaturated compounds. Now, let us examine. Now, examine of saturated hydrocarbons. Example of substitution reaction rather can be seen we can have it a chlorination of methanes. If you have chlorination of methanes, let me give you an example. We have the chlorination of methanes to yield tetrachloromethane. The chlorination of methane to yield tetrachloromethane. Now, let us examine the chlorination. You know, when they mean chlorination means addition of chlorine. So I can say bromination. Bromination is also addition of what? Of bromine. Now, that means if I say halogenation, it means addition of halogens. So that means don't forget, we are still coming to those aspects because they are also known as organic reactions. So I'll be giving you one example under this. Now, if you are saying chlorination now methane is CH4 plus Cl2. Now this is chlorine. Now this is a methane. If you add chlorine to this, it will give you, now this one is 4, it has 4 hydrogen. Now if you check this, it has 4 hydrogen. Now if it's want to bond with Cl2 now if you check this very well, this space is already filled. So one thing that will now happen is that one of this hydrogen will be substituted for one of the chlorine. Now we now have something like this. Now if it has something like this, if you check very well, we've already substituted one of the hydrogen. So the hydrogen we substituted here, we brought it here, we replace one of the chlorine here to this place. So the hydrogen we substituted here is here. Then don't forget that it will remain one of the chlorine here, because the chlorine here is 2. So that's why we don't have this to be, if you check this very well, this one is CH3Cl. CH3Cl plus C plus HCl. But the name of this compound is called chloromethane. Now, this chlorobenzene, which is CH3Cl, can also undergo the same thing. If one of the hydrogen is being replaced, it will remain CH2, but the chlorine will become 2. Then it will give you HCl as well. This one is called dichlorobenzene. Now, if this dichlorobenzene also undergo the same thing, CO2 plus Cl2, it will reduce one of the hydrogens. So the hydrogen becomes 1, then Cl3 plus C plus HCl. Then this one is trichlorobenzene. This one also undergo the same thing. You have CHCl3 plus Cl2. It will give you CCl4 then plus HCl. And this one is tetrachlorobenzene. Now, this reaction occur while we substitute the hydrogen atom in this compound. And don't forget, this process, I can call this process that happen as chlorination. It's an organic reaction. I can call it halogenation because chlorine is part of halogen. So I can call it halogenation. And at the same time, I can say it is what? It is substitution reaction. Can you see that with the process, with the organic reaction, the organic chemistry will be simple for you to understand. Now, let us go to addition reaction. Addition reaction means, don't forget I said direct addition of atoms or group of atoms to an organic compound without replacement or without elimination of the of the atom. Now, example can be say when you have, let's say, I told you that it occurs in unsaturated compounds. Now, an example of unsaturated compounds, we can have alkane and we can have alkyne. But this one occurs in saturated hydrocarbon. That's why we use alkane as an example. That's why we use alkane as an example for this one. Now, we can have, even this one, under substitution reaction, we can have chlorination of benzene. Chlorination of benzene as well, under this substitution reaction. Benzene as well, it's also structured as, it's in a circle form. So chlorination of benzene can also, is also what? Substitution reaction. Now, let's come to addition reaction. Now, this addition reaction, let me use alkyne for instance. Let me use C2. Alkyne family is CnH2n minus 2. And alkene family is CnH2n. This is the formula for the alkane. This is alkane and this is alkyne. Now, let me use ethyne. Ethyne. Don't forget, ethyne is number 2. That will be C2 here. That's 2 times 2 here. That's 4 minus 2. That's 2. C2H2. Now, if this one, if you add hydrogen to this one, it will give you C2H4 because the hydrogen becomes 4. And this one is ethane. This ethane as well, I can make it to, that's C2H4, which is ethane. I can add hydrogen to it, and it will give me C2H6. And this one is what? Ethane. And that is why I can say addition reaction, unsaturated hydrocarbons undergo addition reactions in order for them to be completely saturated. Can you see? The end point of this unsaturated hydrocarbon is to become what? To become saturated completely by undergoing what? Addition reaction. Now, they can ask you that, that this process as well, I can bring out 2 reactions here. This is addition reaction. From here to here, it's add to this. I can even bring out 3 reactions because when you add hydrogen to any compound, it is called hydrogenation. So it is called hydrogenation. Now, when you add hydrogen to any compound, it is also called reduction because addition of hydrogen is called reduction. Don't forget. And at the same time, this is also called addition reaction because it is being added. Now, when you add this to this ethyne, it gives us ethane. And ethane as well can also undergo this addition reaction to become what? Ethane. They can ask you a question that complete hydrogenation. Or let me even get to under hydrogenation, the next aspect. Now, number 3 now. Number 3, let me look at hydrogenation and dehydrogenation. And we have to be taking it very, very short this time around because of the time. Now, hydrogenation and dehydrogenation. Now, hydrogenation means addition of hydrogen to any organic compound, while dehydrogenation means removal of hydrogen to any organic compound, like the one I gave you the other time. Now, if you add hydrogen to a compound, let's say C to H4 as H2 as I gave it to you, plus hydrogen to give you C2H4. So from ethane rather to what? To ethane. The ethane as well, which is C2H4, no ethane. If it's undergo hydrogenation to give you C2H6, which is what? Which is ethane. Now they can ask you that hydrogenation of ethyl gives what? Now can you see hydrogenation of ethyl can give us ethane, but CBT question can give you that complete hydrogenation of ethyl. If it's complete, that shows that complete hydrogenation of ethyl is coming to what? To ethane, is ethane. And as you can see, now the inverse opposite of this reaction is now dehydrogenation. Opposite of hydrogenation is dehydrogenation. Anywhere you see D, it means removal. It means removal. Now let us see. So that shows that I can have C2H6 to give us C2H4 plus H2. Now this is removal of what? Of hydrogen. There's a removal of hydrogen from this ethane to this what? To this ethane. Even they can ask you, that shows that hydrogenation of ethane of ethyl will give us the production of what? Of ethane. And hydrogenation of ethane will give us the production of what? Of ethane. The hydrogenation of ethane will give us the production of what? Of ethane. And at the same time, if you have C2H4, if you remove 2 hydrogen from this, it will remain what? 2 hydrogen. So that's C2H2. So that means I can say the hydrogenation of this ethane will give us what? Will give us ethyl. That is it. You can see that it's very, very simple. Number 5 rather. I'll be talking about oxidation, and at the same time I'll be talking about reduction. Now, oxidations and reduction. Now, don't forget that oxidation, according to the formula, is addition of oxygen or removal of what? Of hydrogen. Removal of hydrogen. We have five terms of defining oxidation and reduction, but this is not the class for oxidation and reduction. Now, reduction can be addition of hydrogen, while you have it to be what? Removal of what? Of oxygen. Now, for oxidation, the process that happen here is removal of hydrogen. So I can call this what? Oxidation. The process that happen here is also removal of hydrogen. It is also what? Oxidation. The process that happen here is addition of hydrogen. I can call it what? Reduction. The process that happen here, it's also addition of hydrogen. So I can call it what? Reduction. Now, for oxidation, I'm going to give you this as an assignment, but I'm going to state it like word. Now, reason with me. Primary alcohol and tertiary and secondary alcohol, we use this. Primary alcohol and secondary alcohol undergo oxidation. They undergo oxidation, that is removal of what? Removal of hydrogen. Removal of hydrogen. So they undergo oxidation. in order to give you aldehyde and what? And ketones. Aldehyde and ketones. They undergo oxidation in order to produce aldehyde and ketones. That shows that primary alcohol undergo oxidation to give aldehyde, and secondary alcohol undergo oxidation to give ketones. Now the same thing, the opposite, if it's inverse like this, that shows that aldehyde, if it want to come to this back, it will undergo what? Reduction. Aldehyde undergo reduction to produce what? Primary alcohol. To produce primary alcohol. And at the same time, ketones undergo reduction in order to produce secondary alcohol. Now, one thing I want you to know is that don't forget that aldehyde is also known as alkana, and ketones are also known as alkanone. Don't forget. Now, your assignment or at the comment section, I want you to give me the reactions, like the oxidation of primary alcohol to aldehyde, and the reactions between secondary alcohol, the oxidation of secondary alcohol to ketones. Just give it to me. The oxidation of primary alcohols to aldehyde and oxidation of secondary alcohol to ketones. Just let me have it. Now, as I move to the sixth one. Now, the sixth one I'll be talking about is all about carboxylation, and another one I have decarboxylation. Now, under this aspect of the carboxylation, I'll be talking about the combustion reaction. Now, the carboxylation that I'm talking about, carboxylation means addition of carbon dioxide. Addition of carbon dioxide, that's CO2. And decarboxylation means removal of carbon dioxide, that's CO2. Now, the reason why I'll be talking about combustion here is because combustion, let me even make it to be number 9, but it's under the subset of decarboxylation, combustion. Now, what is combustion? Now, combustion means the burning of organic compounds in the presence of air to liberate either CO2 or CO, that is carbon dioxide or carbon monoxide. Now, the combustion is the burning of organic compound in the presence of air to produce or to liberate CO2 or CO. That is, I'll be talking about the combustion very soon. I'm coming. Now, when you're talking about the carboxylation, it means addition of what? Of carbon dioxide to an organic compound. But now, I'll just quickly give you a process. A process of photosynthesis now. Photosynthesis is carboxylation. Because if you look at photosynthesis, you have 6H2O plus 6 CO2 to give you C6H12O6 plus 6O2. Now, if you check this very well, it is addition of what? Of carbon dioxide to this. Then it is called what? Carboxylation. So the reason why I'm using this is because carboxylation here does not only peculiar to organic compounds, but once you understood the concept behind carboxylation, you are good to go. And if this is carboxylation, now that means opposite of it from year to year is carboxylation. That means opposite if you have C6H12O6 plus 6O2 to give you 6H2O plus 6CO2. That means the opposite like this from year to year as well is decarboxylation. That means removal of carbon dioxide. But here is addition of carbon dioxide. Addition of carbon dioxide is carboxylation, whereby removal of carbon dioxide is what? Decarboxylation. Now let's talk about the combustion. Now the combustion I told you that is the burning of organic compound in the presence of air to either give us the carbon dioxide or carbon monoxide. Now I'm going to give you some things uh, under the combustion here. I'm going to give you some equations. Now let's have this one will help you whenever you are asked to balance any reactions, maybe under alkane or under alkane. Now for alkane, for instance, if they said the alkane family is born in sufficient oxygen, for sufficient oxygen, we have the formula to be CnH2n plus 2 plus 3n plus 1 over 2 O2 to give us NCO2 plus n plus 1 H2O. This one is C. Or you make use of CXHY plus into brackets X plus Y over 4 O2 to give us XCO2 plus Y over 2 H2O. Now, but if it is insufficient oxygen, in insufficient oxygen, we have it to be CnH2n plus 2, then plus, we have it to be 2n plus 1 over 2 O2, then to give you NCO plus n plus 1 H2O. Now, but for alkanes, we have the formula to be CnH2n, then plus 3n over 2O2 to give us NCO2 plus NH2O. Now let us consider one example of this alkane and one example of this alkane in order to prove this formula correct. Now don't forget, this one is for sufficient, that's why it's give us CO2. But this one is for insufficient, other alkane, that's why it give us CO, that's carbon monoxide. Now let us have this. Now let us have an example. If you are to balance C4H, let's say 10, C4H10, that's butane. C4H10, that's butane. That's 4 times 2, that's 8 plus 2, that's 10. So C4H10, that's butane. Now, if you are following the first formula I gave you, which is CnH2n plus 2 plus 3n plus 1 over 2 oxygen to be NCO2, then plus n plus 1 H2O. Now that shows that your N is what? Is 4. So if we want to balance this, that means anywhere we see N, we replace it as what? As 4. So this becomes C4H10 plus, that's 3 into brackets, our N is 4, that's 4 plus 1 over 2 O2 to give us, that's 4CO2 plus, this is 4 plus 1 H2O. This will be the last aspect under this. Don't forget, this is number 9. Then because of the video, we are going to continue in the next episode. So we still have many more. Make sure you check the videos because this is not the end of the organic reaction. I have like 15, so I'm still continuing. So you watch the next video after this one to get the next organic reaction. Now if you see this very well, it will be C4H10 plus 3 times 4, that's 12 plus 1, that's 15. We have it to be 15 over 2 O2 to give us 4 CO2 plus we have this with 5 H2O. Then this becomes C4H10. Okay, sorry, let's multiply all through by 2 so that to eradicate this. So that will be 2 times, that's 2 plus this one will now become, this one will be 2 times 15 over 2 will be what? 15. Then O2 to give us 2 times 4, that's 8 CO2 plus 2 times 5, that's 10 H2O. So we multiply all through by 2 in order to eradicate the 2 at the denominator here. So this now becomes, let's check if it's balanced. the the carbon here is 8, the carbon here is also 8. The carbon here, the hydrogen here is 20. Hydrogen here is also 10 times 2, that's 20. Oxygen here is 15 times 2, that's 30. We have oxygen here to be 30. This one is 8 times 2, that's 16. Plus this one is uh 10 times 1 here, that's 10. Yeah, that's 10. Sorry, if you observe, there's a mistake here. That's 3 times 4, that's 12, plus 1, that's 13. So this one is 13 here. So it's not 15. So this place is supposed to be 13. So if you check, it affects the number of oxygen. So be 16 times 2 here, that's 26. So this place is 26. So if you have this to be 26, this one is 10 times 1 here, that's 10. This one is 26. And the oxygen here will be 8 times 2. 8 times 2 here will be 16. Then plus, you have this to be 10 times 1, that's 10, making it to be 26 as well. Sorry, the mistake is from here. So if you calculate it very well, it's 13 that's supposed to be here, 13. Because 3 times 4 will be 12, plus 1, that's 13 over 2. So this is supposed to be 13. Now if you check it very well, this is how to balance this. Now let us use the second formula, which is CXHY plus X plus Y over 4 O2 to give us XCO2 plus Y over 2 H2O. Now if you check this very well, let's balance C3H. C3 times 2, that's 6, plus 2, that's 8. Let's balance this. Now you now observe that shows that our X is 3, then our Y is what? Is 8. Our Y is 8. So this becomes, we have 3 plus 8 over 4 O2 to give us, we have our X, which is 3 CO2 plus our Y is 8 over 2 H2O. Now if you observe, this becomes C3H8 plus, we have 4 here 1, 4 here to be what? 2. That's 3 plus 2, that's 5 O2 to give us 3 CO2 plus 2 here 1, 2 in 8, that's 4. That's 4 H2O. Now let us check if it's balanced. The carbon here is 3. The carbon here is also 3. Hydrogen here is 8. 4 times 2 is also 8. Oxygen here is 5 times 2, that's 10. Oxygen here is 5 times 2, that's 10. We have the oxygen here to be 3 times 2 here, that's 6. Plus 4 times 1, that's 4. Making it to be what? 10 as well. It shows it's balanced. So this is for sufficient alkanes. Now you can do for insufficient alkanes, as I gave you the formula. Don't forget, as I said, that this is for sufficient and this is for what? Insufficient oxygen for alkanes. Now let me give you one under alkane so that we can end it up here. Under alkane, let's have one. Let's say you have C2H. That's alkane is CnH2n. So that will be C2. That's 2 times 2. That's 4. Don't forget, if you are to balance this, the formula I gave you is Cn H2n plus 3n over 2 O2 to give you NCO2 plus NH2O. So if you now have this, that means our N is what? Is 2, according to this. Now because we have C2H4 plus 3 into bracket 2 over 2 O2 to give us 2 CO2 plus 2 H2O. This becomes C2H4 plus 3 times 2, that's 6, over 2, that's 3. O2 to give us 2 CO2 plus 2 H2O. Let us check if it's balanced. We have the carbon here to be 2, carbon here to be 2, and the carbon here as well to be 2. Hydrogen here is 4, and hydrogen here is also 2 times 2 here, that's 4. Oxygen here is 3 times 2, that's 6. We have oxygen here to be 6. And oxygen here is 3 times 2 here, that's 2 times 2 here, that's 4. Then plus 2 times 1 here, that's 2. That makes it to be 6. So it's balanced. So at this junction, you have to watch the next video so that you can get the next aspects of the words of the organic reaction. So I still have 15 more. So the continuation, please subscribe, like, and comment. Don't forget the assignment I gave you in this class, the oxidation reaction of the primary alcohol to aldehyde and the oxidation of the secondary alcohol to ketones. Tell me in the comment section. I want to see the reaction. Thank you very much. God bless you.